All matter in the universe is made of atoms, often combined as molecules. The smallest molecule consists of 2 hydrogen atoms, and the largest, Pg5, contains roughly 20 million atoms. Molecules are groups of atoms bonded together, kind of like bonds between people in couples, in family, or between owners and pets. So, what are chemical bonds? Consider a hydrogen atom moving in space. If another hydrogen atom gets close enough, they can create a chemical bond. This bond is called covalent because the atoms share a pair of electrons. The 2 hydrogen atoms remain at a given bonding distance where overall their interaction stabilizes them energetically. Just like a bond is made, it can be broken, for instance by heating the molecule or from a collision with another molecule or atom. Now, do all atoms bond? Well, it depends on the element. For instance, noble gases have no space to make bonds. On the other hand, carbon has space to share 4 electron pairs, so it can make 4 bonds, like the 4 single bonds in methane, or the 2 double bonds in carbon dioxide. What do we need to describe a molecule? As humans, we can be identified by an ID card. It contains our name, date of birth, and picture. For molecules, each comes with a unique name, like methane, a graphic representation such as a 3D structure, and a unique international chemical identifier string, INCHI. Our names are usually chosen by our parents. On the other hand, molecules have IUPAC, the International Union of Pure and Applied Chemistry. It's the world authority on defining unique names for molecules, amongst other things. Some molecules have several names. Consider caffeine, the molecule in your coffee that gives you a buzz of energy. It was first isolated by a German chemist and then written in a French chemist's article in the early 1800s. Long story short, it comes from coffee in French, café, or in German, Kaffee. The name caffeine stuck, probably because it's much simpler than its long IUPAC name. Now, how do we represent a molecule? Wouldn't it be awesome if they could take selfies? Well, unfortunately they're way too small with respect to a cell phone, like 30 million times too small. So, in absence of molecular selfies, we represent them based on how the atoms are bonded. Consider water. There are 16 billion quadrillion water molecules in a 16-ounce glass of water. So let's zoom in. The water molecule has 2 hydrogens bonded to 1 oxygen atom. We can write its formula as H_2O. Another option is to show bonds with solid lines. Unbonded electrons are sometimes shown as dots, 1 per electron, or as a short line above the atom, 1 per pair of electrons. The water molecule is shaped like an inverted V because the space on top of oxygen is occupied by 4 unbonded electrons. Finally, if we know the exact position of each atom in time, we can make a 3-dimensional plot of the molecule moving in space. New molecules have been discovered at an exponential rate over the past 200 years. Their variety is uncountable. Together, they can combine to create large, complex structures. These, in turn, are minuscule dots in our universe where an infinity remains to be uncovered. Thanks for watching, and if you liked this video, give it a thumbs up